Hello, and welcome to Discover Before Sleep channel. Tonight, I will tell you the story of a man who discovered something impossible. 120 years ago, in a small office in Switzerland, a young clerk stared at a clock and realized it was lying. That man was Albert Einstein. He discovered that time slows down, that light never changes, and that the present is not the same for everyone. And in that quiet moment, the universe broke. So get comfortable, take a deep breath, and let us begin. The dust motes dancing in the shafts of afternoon light were the only things in the room that seemed to move without purpose. Everything else in the Swiss patent office on the Speichergasse was rigid, ordered, and suffocatingly linear. It was the spring of 1905, and Bern was a city of stone and clockwork, a place where the rhythmic ticking of machinery measured out the lives of its citizens with indifferent precision. Inside the cramped office, the air smelled of stale tobacco smoke, dry paper, and the sharp, metallic tang of ink. Albert Einstein sat perched on a tall wooden stool, his back hunched over a sprawling diagram of an electromagnetic synchronization device. He was 26 years old, a technical expert, Class 3, a title that sounded grander than the reality of his existence. To the casual observer, he was a failure of the academic world, a physics dropout who couldn't secure a teaching position, a man whose brilliant potential had seemingly evaporated into the mundane fog of civil service. His suit was slightly too large, the fabric worn at the elbows, and his hair, though not yet the chaotic halo of his later years, already refused to obey the conventions of a proper Swiss grooming. He dipped his pen into the inkwell. The scratch of the nib against the paper was loud in the silence of the room. He was supposed to be evaluating the merit of a new invention, a system designed to coordinate the clocks of railway stations across the canton. It was a practical problem, a matter of wires and signals and gears. The world in 1905 was obsessed with synchronization. Trains needed to run on time, the telegraph had shrunk the distance between cities, the industrial age demanded that a second in Zurich be the exact same second in Geneva. But as Albert stared at the schematics, the rigid lines of the technical drawing began to blur. He looked up from the desk. The window offered a view of the tiled roofs of Bern, sloping down toward the Aare River, and in the distance, the towering dominance of the Bernese Alps, white and eternal against the blue sky. But his eyes were drawn to the Zittglaube, the medieval clock tower that stood as the heartbeat of the city. He watched the minute hand jerk forward. A mechanical spasm. A slice of existence chopped off and discarded. To everyone walking on the cobbled streets below, that clock was the absolute authority. It told them when to wake, when to work, when to eat, and when to sleep. Time was a river that flowed at a steady, unchangeable pace, the same for the king as for the beggar, the same for the patent clerk as for the stars. It was the stage upon which the universe acted, a silent, invisible container that held everything but touched nothing. Newton had said it was so. The great Isaac Newton, whose laws governed the falling apple and the orbiting moon, had declared time to be absolute, true, and mathematical. Albert rubbed his temples. The headache was returning, a pressure behind his eyes that had been building for months. He felt a dissonance, a vibrating tension between the reality he was supposed to accept and the intuitive whispers of his own mind. He looked back at the patent application. The inventor claimed that by sending an electric signal from a master clock to a slave clock, time could be made simultaneous. Simultaneous. The word echoed in Albert's mind, detaching itself from the technical jargon. What did it actually mean for two things to happen at the same time? If a train conductor in Bern checks his watch at the exact moment a bolt of lightning strikes a field in Murray, are those events truly simultaneous? Or is it a trick of perception? He pushed the papers away, creating a small avalanche of bureaucratic forms. He felt like an imposter in this room. His boss, Herr Haller, valued him for his ability to strip away the complex language of inventors and find the core physical principle, but Haller had no idea that Albert was stripping away the reality of the universe itself. While his hands stamped approvals and rejections, his mind was spinning in a void where the laws of physics were breaking down. The silence of the office was punctuated by the rhythmic coughing of a colleague in the next row, a sound that marked the passage of the afternoon as surely as the clock. Albert felt a profound sense of isolation. He had friends, the Olympia Academy, where they drank cheap wine and debated philosophy, but even they could not fully grasp the storm raging inside his head. He was wrestling with a ghost. He was trying to reconcile the mechanics of Galileo with the electromagnetism of Maxwell, and they refused to fit. One demanded that speeds add up, the other insisted that the speed of light was a constant, an unbreakable cosmic speed limit. He stood up and walked to the window, pressing his forehead against the cool glass. Below, the electric trams rattled along the tramgas, sparks flying from the overhead lines. People moved in jerks and starts, hurried by the invisible whip of time. They trusted the clock. They believed that the now they experienced was the same now experiencing by a person on the other side of the world, or on the moon, or on the sun. Albert closed his eyes. The physical world of the patent office faded, the smell of dust, the scratching pens, the heavy furniture. In the darkness behind his eyelids, he didn't see gears or wires. He saw geometry. He saw grids of light warping and stretching. He felt the sensation of motion, deep in his gut, the feeling of falling without hitting the ground. He was a young man with a baby at home and a wife, Maliva, who was struggling with her own lost ambitions. He had bills to pay. He had a reputation for arrogance and laziness to overcome. Yet, standing there in the fading light of a Swiss afternoon, Albert Einstein felt the terrifying thrill of an explorer standing on the edge of a map. He knew, with a certainty that defied logic, that the clock tower outside was lying. The great Ziegler struck the hour. The heavy bells resonated through the glass, vibrating in Albert's chest. 1, 2, 3, 4, 5. 5 o'clock. The workday was ending. The other clerks began to shuffle their papers, sliding ledgers into drawers, capping their inkwells. The ritual of closure. But for Albert, the day was not ending, the question was merely waking up. He returned to his desk, not to pack up, but to stare one last time at the synchronization patent. Herr Einstein. It was Haller's voice, stern and grounding. Albert blinked, the geometric visions dissolving back into the dim reality of the office. Yes, sir. The report on the alternating current motor. Is it finished? Almost, sir. Tomorrow morning. Haller grunted, a sound of mild disapproval, and turned away. Albert watched him go. The man was solid, anchored in the Newtonian world where mass was mass and time was time. Albert picked up his hat. He felt a strange affection for these people, for this room, for the very boredom that forced his mind to wander into forbidden territories. It was here, in the quiet monotony of the patent office, that he was free. The academic world had rejected him, and in doing so, they had liberated him. He had no professor to please, no thesis to defend. He only had the truth, and the truth was hiding somewhere between the ticking of the clock and the beam of light he had been chasing since he was a boy. He walked out of the office and into the cool evening air of Bern. The gas lamps were flickering to life, casting long, dancing shadows on the cobblestones. He began his walk home, his pace slow, his eyes unfocused. The city moved around him, a clockwork mechanism of flesh and stone, unaware that the young man walking with his hands in his pockets was about to grab the hands of the universe's clock and bring them to a grinding, impossible halt. The walk home through the twilight streets of Bern was a journey through the present, but Albert's mind was slipping backward, drifting on the current of memory to a time before patents and equations, before the crushing weight of adulthood. The gas lamps blurred into the soft, diffuse light of a different room, in a different city, decades ago. The smell of the Swiss River was replaced by the scent of lavender and stale medicinal vapors. He was 5 years old again, lying in a high bed in Munich. The world was a place of fever and stillness. He was a quiet child, one who had been slow to speak, a boy who looked at the world with wide, dark eyes that seemed to take in more than they could process. He felt the scratchy wool of the blanket against his chin and watched the dust motes swirling in a shaft of sunlight that pierced the heavy velvet curtains. He was ill, confined to the bed, his universe shrunk to the four walls of his room. The door creaked open, breaking the silence. His father, Hermann, stepped inside. Hermann was a man of commerce, a manufacturer of electrical equipment, a man who smelled of cigars and optimism. He walked to the bedside, his footsteps heavy on the floorboards, and sat down on the edge of the mattress. The mattress dipped under his weight, shifting Albert's small body. Hermann smiled, a warm, reassuring expression that crinkled the corners of his eyes, and reached into his vest pocket. "I have something for you, Albert," he said softly, his voice a low rumble in the quiet room. "Something to keep you company." He withdrew a small, round object. It glinted in the dim light. It looked like a pocket watch, the kind grown men checked to see if they were late for meetings, but it had no numbers, no ticking hands counting away the seconds. It was a compass. Albert reached out, his small, pale hand trembling slightly from the fever. The metal was cool and heavy against his palm, a shocking contrast to his hot skin. It felt solid, permanent. He looked down at the face of the device. Beneath the glass cover, a slender needle, painted red on one tip, balanced on a delicate pivot. It quivered with a life of its own, trembling like a nervous bird. He turned the compass in his hand, rotating the brass casing. He expected the needle to turn with it, just as a toy soldier turns when you spin the platform it stands on. In the world Albert understood, the world of balls and blocks and wooden trains, things only moved if you touched them. Things went where you put them and stayed there until you moved them again. That was the rule. That was the law of the nursery. But the needle did not obey. As Albert rotated the casing to the left, the needle stubbornly remained pointing in the exact same direction. He turned it to the right, faster this time. The needle ignored him. It floated, suspended in the air, indifferent to the movement of the casing, indifferent to Albert's hand, indifferent to the room itself. It was locked onto something else, something invisible, something distant, something incredibly powerful. A cold shiver that had nothing to do with his fever ran down Albert's spine. He sat up, pushing the blankets away. He shook the compass. The needle danced wildly for a moment, chaotic and panicked, but as soon as the motion stopped, it settled back, relentlessly returning to its silent vigil. North. Always north. He looked around the room. The air between his eyes and the far wall looked empty. It looked like nothing. It was just space, a void where nothing existed. But the compass was telling him a different story. The compass was screaming a secret. The empty space wasn't empty at all. It was full. It was alive with a force he couldn't see, couldn't smell, couldn't touch, yet which held the needle in an iron grip. For the young boy, the walls of the bedroom seemed to dissolve. The reality he thought he knew, the solid, tangible reality of tables and chairs, suddenly felt thin, like a painted backdrop in a theater. Behind that backdrop, there were gears turning. There were invisible hands reaching out across the universe to guide this tiny piece of metal. He felt a sensation that he would later describe as Das Wunder, a deep, resonant wonder that struck him with the force of a physical blow. It was a feeling of awe, bordering on fear. If the air was full of invisible forces that could reach through walls and bodies to hold a needle in place, what else was out there? What other ghosts haunted the empty spaces? He spent hours that afternoon playing with the compass. He brought it close to the iron bed frame, watching the needle deviate, realizing that matter interacted with this invisible force. He spun in circles until he was dizzy, watching the needle hold its ground. He was conducting his first experiment, not with mathematics, but with pure, unadulterated sensation. The silence of the room deepened as the afternoon wore on, but it was no longer a lonely silence. It was a pregnant silence, heavy with mystery. The boy realized then, with a clarity that would define the rest of his life, that the surface of the world was a lie. The things we see, the wood, the stone, the flesh, are merely the skin. The muscle and bone of the universe are hidden, woven into the fabric of space itself. Most children would have played with the toy for an hour and then discarded it for a tin soldier or a picture book. But Albert lay back on his pillow, clutching the cool brass against his chest, staring at the ceiling. He was not just looking at the plaster, he was trying to see the structure of the empty air. He felt a desperate, burning need to understand the mechanism behind the magic. Whatever this force was, it was rigid. It was reliable. It was a rule that the universe had to follow. And if there was a rule for the needle, there had to be rules for everything else. Rules for the light streaming through the window. Rules for the heat radiating from his body. Rules for the stars he could see from his window at night. The seed was planted in that fevered, quiet room in Munich. The patent clerk walking the streets of Bern 20 years later was merely the blossom of that initial moment of shock. The boy with the compass had learned that the universe had a hidden architecture. He had learned that empty space was a physical thing, capable of pushing and pulling, capable of acting and being acted upon. As the memory faded, merging back into the rhythm of his footsteps on the Swiss pavement, the sensation remained. The feeling of the invisible grip. He was still that boy, holding the compass, only now the needle wasn't pointing north. It was pointing toward a beam of light, and he was trying to understand what invisible hand was holding the speed of the universe steady, no matter how fast he ran. The mystery of the magnetic field had become the mystery of time itself. The wonder had never left him, it had only grown, expanding until it threatened to swallow him whole. The years drifted by, not in the rigid ticks of a clock, but in the fluid, chaotic expansion of a young mind growing too large for its surroundings. The scene shifts from the dim bedroom in Munich to the sun-drenched, rolling hills of Aarau, Switzerland. It was 1895. Albert was 16 years old, a student at the cantonal school, a place that finally allowed him to breathe after the suffocating, militaristic education of Germany. Here, in the clean Swiss air, he was free to question, free to dream, and most importantly, free to ride his bicycle. The bicycle was his laboratory on wheels. He pedaled furiously along the country roads, the wind whipping through his unruly hair, the tires humming against the gravel. He loved the sensation of speed, the way the world blurred at the edges of his vision. It was the only time he felt truly synchronized with the motion of the universe. But even as his legs pumped the pedals, pushing him faster and faster, his mind was racing far ahead, leaving his physical body behind to grapple with a question that had begun to haunt his waking hours. It was a question born of a simple, almost childish daydream, yet it contained the seeds of a revolution. He looked up at the sunlight filtering through the canopy of trees, the beams cutting through the air like solid pillars of gold. Light. It was everywhere. It was the messenger of the universe, bringing news of the stars, the sun, and the faces of friends. But what was it? Maxwell, the Scottish physicist whose equations Albert worshipped, had described light as an electromagnetic wave, a rippling dance of electric and magnetic fields undulating through space at a specific, immutable speed, c. A speed of approximately 300,000 kilometers per second. A number so fast it rendered human imagination impotent. Albert gripped the handlebars, his knuckles white. He narrowed his eyes against the glare. He imagined himself accelerating. He imagined pushing the pedals harder, not just to go 20 kilometers an hour, or 30, but faster. Much faster. He imagined shedding the weight of his body, the friction of the road, the drag of the air. He imagined flying alongside that beam of light, racing it like a train racing a parallel track. "If I chase a beam of light with the velocity c," he whispered to the rushing wind, "what would I see?" The question hung in the air, defiant and terrifying. According to Isaac Newton, the answer was simple. Newton's world was a world of addition and subtraction. If you run at 10 miles an hour and throw a ball forward at 10 miles an hour, the ball moves at 20. If you run alongside a train moving at 50 miles an hour, and you run at 50 miles an hour, the train appears to stand still relative to you. You can look through the window, wave at the passengers, and read the newspapers in their hands. Relative to you, the train is frozen. So, Albert reasoned, as his bicycle coasted down a hill, if he caught up to the beam of light, if he matched its speed exactly, he should see the light wave frozen in space. He should see a stationary, spatially oscillatory electromagnetic field. He visualized it in his mind's eye, a frozen wave of energy, locked in place like a ripple in a frozen pond, the electric peak suspended forever, never crashing, never moving. But as the image formed, a deep, nauseating sense of wrongness settled in his stomach. Maxwell's equations did not allow for a frozen wave. Light, by its very definition, was a traveling disturbance. It existed only because it moved. The changing electric field created the magnetic field, and the changing magnetic field created the electric field. They sustained each other in a perpetual, moving cycle of creation. If the motion stopped, the fields would collapse. The light would vanish. So, here was the paradox that threatened to tear Albert's mind apart. If he caught the light, he should see it frozen, according to Newton. But if it was frozen, it couldn't exist, according to Maxwell. He braked hard, the bicycle skidding to a halt on the dusty road. He put a foot down to steady himself, his chest heaving not from exertion, but from the intellectual vertigo. The silence of the Swiss countryside was deafening. The cows grazing in the distance, the white-capped mountains, the sleepy farmhouse, they all seemed oblivious to the crisis in physics that was playing out in the mind of a teenager on a bicycle. He looked at his hands. They were matter. They obeyed Newton. He looked at the sun. It was light. It obeyed Maxwell. Why did the universe have two sets of laws? Why did the rules for the stone and the planet differ from the rules for the lightning and the star? He tried to approach the problem from another angle. Imagine he was holding a mirror in front of his face while flying at the speed of light. If he was moving at c, and the light leaving his face was also moving at c, the light would never catch up to the mirror. To him, the mirror would be completely dark. He would have no reflection. He would be a vampire, a ghost in the machine. But that felt wrong too. If he was moving at a constant speed, even a very fast one, physics said he shouldn't be able to tell he was moving without looking outside. If he was in a closed room moving at light speed, shouldn't he still be able to comb his hair in the mirror? If the reflection disappeared, it would prove he was moving, violating the principle of relativity that Galileo had established centuries ago. Albert stood by the side of the road for a long time, the bicycle leaning against his hip. The sun beat down on his face, a relentless stream of photons mocking him. He realized then that the beam of light was not just a physical phenomenon, it was a barrier. It was a limit. It was a tantalizing clue that the intuitive understanding of space and time, the understanding that every human being is born with, was fundamentally flawed. He felt a profound sense of loneliness. He couldn't explain this to his teachers, they would tell him to focus on his rote memorization. He couldn't explain it to his classmates, they were worried about exams and girls. He was alone with a beam of light that refused to be caught. He pushed the bicycle back onto the road and began to pedal again, slowly this time. The euphoria of speed was gone, replaced by a heavy, brooding determination. He knew he couldn't outrun the light. Not yet. But he promised himself, as the wheels turned and the gravel crunched, that he would not rest until he understood why the universe refused to let him stand still alongside a wave of light. He would chase it, not with his legs, but with his mind, until he cornered it and forced it to give up its secret. The race had begun, and the finish line was a decade away, hidden in the mists of the future, waiting for a patent clerk to cross it. The dusty floorboards of the patent office were gone, replaced in his mind by the rhythmic, heavy clatter of a railway carriage. Albert was no longer a man sitting at a desk, he was an observer standing on an embankment, watching a train scream past him at a velocity that defied common sense. This was the laboratory of his imagination, a place where he could manipulate the very fabric of reality to see where it tore. He visualized a long, sleek train moving along a perfectly straight track. In the center of the carriage stood a passenger. Above, the sky was a bruised purple, heavy with the threat of a storm. At the exact moment the midpoint of the train passed Albert on the embankment, two bolts of lightning struck, one at the front of the train, and one at the rear. To Albert, standing still on the solid earth, the flashes were instantaneous. The twin pillars of light scorched the air at the same precise moment, leaving charred marks on the track and the carriage. He saw them simultaneously. But then, he shifted his perspective. He climbed inside the mind of the passenger on the train. The passenger is rushing toward the bolt of lightning at the front and fleeing from the bolt at the rear. Because the speed of light is constant, the same for the man on the ground and the woman on the train, the light from the front strike has a shorter distance to travel to reach the passenger's eyes. The light from the rear strike must chase the train, traveling a longer distance to catch up. In the silence of his internal theater, Albert watched the passenger react. The passenger saw the flash at the front first. Then, a fraction of a heartbeat later, they saw the flash at the rear. To the person on the train, the events were not simultaneous. They were sequential. Albert felt a jolt of intellectual electricity that was more powerful than the lightning in his mind. He leaned forward, his elbows digging into the wood of his desk in Bern. The implication was a physical blow to the stomach. If two observers, moving at different speeds, cannot agree on whether two events happened at the same time, then simultaneity is a phantom. There is no now that belongs to the entire universe. He looked at the clock on the wall of the patent office. He realized that the now happening inside the clock's casing was not the same now for a bird flying past the window, or for a planet spinning in the dark. Time was not a universal heartbeat. It was not a steady, invisible rain falling equally on everyone. Instead, time was personal. It was a tethered shadow, stretching and contracting depending on how fast one moved. The faster the train moved, the more the passengers, now, would drift away from Albert's, now. If the train could reach the speed of light, the very sequence of the universe would warp. This was the death of Newton's absolute time. The great English master had envisioned time as a giant, cosmic clock in the sky, ticking away with divine indifference. But Albert, sitting in the mundane quiet of a government office, saw that the clock was broken. Or rather, there was no clock at all. There were only millions of individual clocks, each one valid, each one correct, yet all of them disagreeing with one another the moment they began to move. He began to pace the narrow aisle of the office. The other clerks ignored him, used to the eccentricities of the technical expert. He felt a sense of vertigo, as if the floor beneath his feet had turned into water. If time was not absolute, then space could not be absolute either. They were locked together in a dizzying dance. To keep the speed of light constant, the one fixed point in a crumbling reality, time and space had to be the variables. They had to give. They had to bend. He thought of the passenger's watch. If the passenger moved fast enough, their seconds would have to stretch. Their time would have to slow down relative to his, just to ensure that the light they saw still moved at that magical, unbreakable speed of c. The realization was terrifyingly beautiful. It was a cosmic trade-off. The universe was willing to sacrifice the constancy of time itself just to preserve the sanctity of light. Light was the master, time was the servant. He stopped pacing and looked out at the city of Bern. He saw the trams, the people, the distant mountains, and for the first time in his life, he saw them as they truly were, travelers in time, each encased in their own private bubble of duration. He felt like he had pulled back a heavy curtain to reveal a stage that was far more vast and far more strange than anyone had ever dared to imagine. The world was not made of objects in time, it was made of events in a four-dimensional tapestry where the past, present, and future were mere illusions, however persistent. The headache that had plagued him for weeks suddenly vanished. In its place was a crystalline, freezing clarity. He knew what he had to do. He had to rewrite the laws of the world. He had to explain how a train, a bolt of lightning, and a beam of light had conspired to show him the true nature of eternity. He turned back to his desk, took a fresh sheet of paper, and began to write, his hand moving with a newfound, desperate urgency. The realization did not come with a shout or a flourish, it came with a silence so profound it felt as though the world had stopped breathing. Albert sat at his desk, the ink on his pen drying, as the final piece of the mosaic clicked into place. He saw it now, not as a series of equations, but as a fundamental truth of the architecture of existence. Time was not the master of light, light was the master of time. For centuries, humanity had lived under the tyranny of the absolute. We believed that a second was a second, a fixed unit of reality that marched forward with the same rhythm everywhere in the cosmos. But Albert, staring at the dust motes in the afternoon sun, understood that this was a provincial delusion. Time was a local phenomenon. It was a fluid, elastic medium that could be stretched like taffy or compressed like a spring. He leaned back, his heart hammering against his ribs. He understood that the sacrifice the universe was making. To ensure that every observer, no matter how fast they moved, measured the speed of light as exactly the same c, the universe was willing to warp its own heartbeat. If you traveled faster, your time would dilate. Your clocks would tick slower. Your heart would beat fewer times. Your very cells would age with a different, more languid rhythm than those of the people you left behind on the stationary Earth. This was the special theory. It was special because it dealt with the specific case of constant, uniform motion. He realized that the faster an object moved through space, the slower it moved through time. They were two sides of the same coin, a four-dimensional continuum he began to conceptualize as spacetime. If you used up your quota of motion by racing through the three dimensions of space, you had less motion available for the fourth dimension of time. He thought of his friend Michel Besso, with whom he had spent hours walking and debating these ideas. Only the day before, he had told Michel he was giving up, that the problem was unsolvable. But after a night of fitful sleep, the fog had burned away. He had gone to Michel this morning and said, "Thank you. I've completely solved the problem." The problem was the nature of reality itself. Albert saw that if time was relative, then the very concept of distance was relative too. To the passenger on the high-speed train, the track itself would appear to shorten. The world would contract in the direction of motion. Everything was in a state of flux, a cosmic dance of shifting perspectives where the only constant, the only absolute truth, was the ghostly, shimmering velocity of light. He felt a sense of immense weightlessness. The walls of the patent office, the city of Bern, the mountains, the very stars above, they were no longer solid, immovable fixtures. They were participants in a grand, elastic theater. He felt like a man who had been born in a dark room and had suddenly found the light switch. The world was stranger than the poets had dreamed, more mathematical than the priests had claimed, and more beautiful than the scientists had dared to hope. He looked at his own reflection in the window. If he were to travel at 99% the speed of light to the star Alpha Centauri and return, he would find his son Hans Albert grown into an old man, while he himself had aged only a few years. He would be a traveler from the past, a ghost who had skipped across the ripples of time. The tragedy of human mortality was suddenly intertwined with the physics of the vacuum. The simplicity of it was what haunted him. It wasn't that the equations were difficult, the math was actually quite elegant, it was that the leap of imagination required one to abandon everything they thought they knew about common sense. Common sense, Albert realized, was merely the collection of prejudices acquired by age 18. To see the truth, he had to become like a child again, the boy with the compass who didn't know that space was supposed to be empty. He picked up his pen again. The words began to flow, not with the dry tone of a bureaucrat, but with the rhythmic power of a creator. He was writing on the electrodynamics of moving bodies. He was not just writing a paper, he was composing a eulogy for the old world and a birth certificate for the new. The ink was the blood of a revolution. He knew that when these pages were published, the name Albert Einstein would either be synonymous with a madman or with the man who had finally looked into the eye of God and seen the clockwork of eternity. He felt a deep, humble gratitude. He was a clerk, a father, a husband, a man who liked violins and long walks, and yet, for a brief, flickering moment, the universe had whispered its greatest secret into his ear. He promised himself he would never let the secret go. Time had been discovered, not as a ruler, but as a companion, and nothing would ever be the same again. The year 1905 arrived in Bern not with a thunderclap, but with the quiet scratching of a fountain pen in a small apartment at Kramgas 49. Outside, the world was preoccupied with the Russo-Japanese War and the burgeoning unrest in the streets of St. Petersburg, but inside Albert's study, a different kind of revolution was being drafted by candlelight. This was his annus mirabilis, his miracle year. It was a period of sustained intellectual intensity that bordered on the supernatural, a time when the veil between a solitary human mind and the fundamental laws of the cosmos seemed to wear thin and finally tear. In those months, Albert was not just a physicist, he was a conduit. He worked at the patent office by day, his mind bifurcated between the mundane reality of elevator pulleys and the soaring abstractions of the universe. When he returned home to Mileva and their young son, he did not rest. He sat at his small wooden table, surrounded by piles of tobacco ash and half-finished cups of coffee, and produced 4 papers that would forever alter the course of human history. The first dismantled the very nature of light, suggesting it was composed of discrete packets of energy, quanta, a discovery that would later birth the strange world of the subatomic. The second proved the existence of atoms by observing the frantic, microscopic dance of pollen in water. But it was the third and fourth papers that struck at the heart of time and existence. He was redefining the coordinates of reality. He wrote with a terrifying economy of language. He did not need complex laboratory equipment or a team of assistants, his laboratory was his own mind, and his tools were thought experiments. He took the realization from the train and the lightning bolts and codified it into the special theory of relativity. He stripped away the ether, that invisible fluid scientists believed filled space, and declared that space itself was a void that didn't need a medium. He threw out the absolute, now, and replaced it with a web of relative perspectives. As the weeks bled into one another, the exhaustion began to take hold. His eyes were bloodshot, and his clothes smelled perpetually of the black sweat of intense labor. Yet, he felt a strange, manic energy. One afternoon, as he was finishing the paper on relativity, a further thought occurred to him, a mathematical afterthought that seemed almost too simple to be true. If time and space were linked, then what of matter and energy? He looked at the equations. He saw that mass was not a static, dead thing. It was a colossal reservoir of trapped energy. He scribbled down a relationship that would become the most famous sequence of symbols in the history of the species. Energy E is equal to mass m multiplied by the square of the speed of light c. Because the speed of light is such a massive number, even a tiny speck of matter, a grain of sand, a drop of water, contained within it the power of a star. He put his pen down and stared at the paper. The equation was a bridge. It linked the solid world of things we can touch to the ethereal world of light and radiation. It suggested that time, space, matter, and energy were not separate rooms in the house of the universe, but rather a single, continuous fabric. He felt a sense of profound humility, a feeling that he was not so much inventing these truths as he was uncovering a masterpiece that had been hidden in plain sight since the beginning of time. By the end of 1905, Albert was physically spent. He had rewritten the rules of the game while working a 48-hour week as a low-level civil servant. He sent his papers off to the Annalen der Physik, the prestigious journal in Berlin, and then he waited. He went back to the patent office. He checked the drawings for a new type of gravel sorter. He walked his son in the park. He waited for the world to notice that the foundation of the earth had shifted. The silence that followed was deafening. For months, there was nothing. No letters of praise, no frantic telegrams from famous professors, no invitations to speak at universities. The papers sat in the libraries of Europe like unexploded bombs. Albert began to wonder if he had made a mistake, if his logic had a flaw he had missed in his feverish haste. He felt the cold touch of doubt. Was he just a deluded clerk in a minor Swiss city, dreaming of things he couldn't possibly understand? But the truth he had found was too elegant to be wrong. It had a mathematical music to it, a resonance that echoed the harmony of the spheres. He continued to go to the office, continued to stamp his patents, but he knew that the man who had entered the year 1905 was not the man who was leaving it. He had tasted the forbidden fruit of absolute clarity. He had seen the secret architecture of the clock, and even if the world chose to ignore him, he knew that the ticking of the Zickglock would never sound the same to him again. He was no longer a resident of Bern, he was a citizen of the space-time continuum. The silence of the academic world was not a vacuum, it was a wall of cold, aristocratic indifference. As 1906 and 1907 drifted by, Albert remained at his desk in the patent office, still a technical expert, class 2, while the giants of European physics continued their lectures as if the foundations of their universe hadn't been set on fire. To the professors in Berlin, Vienna, and London, the idea that a 26-year-old clerk, a man without a doctorate, a man who had been a mediocre student, could dismantle the sacred laws of Isaac Newton was not just improbable, it was an insult. He would open the latest physics journals with trembling fingers, searching for his name, searching for a rebuttal, a critique, anything that proved he was being heard. Often, there was nothing. When the silence finally broke, it wasn't with a roar of approval, but with the sharp, biting wind of skepticism. Traditionalists viewed his work as mathematical acrobatics, devoid of physical reality. They mocked the idea that a clock could slow down simply because it was moving. It offended their senses. It violated the common sense of a generation that believed the universe was a solid, dependable machine. Albert felt the sting of this isolation deeply. He was a man who craved intellectual companionship, yet he found himself an island. In the corridors of the great universities, whispers circulated about the arrogant young Jew in Bern who thought he was smarter than the giants of the 17th century. He was called a dreamer, a man lost in a fog of abstractions. Some even suggested his theories were a form of Jewish physics, a slur that hinted at the dark political storms gathering on the horizon of the new century. The rejection was not just professional, it was visceral. He was denied promotions. His applications for teaching positions were met with polite, icy rejections. He was a man who had seen the gears of the cosmos turning, yet he was still required to spend 8 hours a day analyzing the mechanics of a new type of fountain pen or an improved hydraulic pump. The dissonance was maddening. He felt like a prophet who had returned from the mountain with the tablets of law, only to find the people arguing over the price of grain. But within the struggle, a change was occurring. The very rejection that sought to bury his ideas only forced him to sharpen them. He didn't retreat. He didn't recant. Instead, he began to push further. He realized that his special theory was incomplete. It dealt with objects moving at a constant speed, but the real world was a place of acceleration, of falling, of turning. And most importantly, it was a world of gravity. He spent his evenings walking through the darkening streets of Bern, his coat collar turned up against the chill. He began to wonder, if everything is relative, what happens to gravity? Newton had described gravity as an instantaneous force, a mysterious tug that reached across the void. But if nothing, not even gravity, could travel faster than light, then Newton's gravity was impossible. It would take 8 minutes for the Earth to know the sun had vanished. One afternoon, while sitting in his office chair, a thought struck him with such force that he nearly fell. He called it the happiest thought of my life. He imagined a man falling from the roof of a house. For that man, in the brief moments of his descent, gravity would effectively vanish. He would be weightless. He would be in a state of freefall, just like an astronaut in orbit. In this moment of profound empathy for a falling man, Albert saw the bridge. Gravity and acceleration were the same thing. They were indistinguishable. This was the equivalence principle. It was the key that would unlock the door to his general theory, but the path toward it was a path of agony. For years, he wrestled with mathematics that exceeded his grasp. He felt his way through a dark tunnel, his fingers brushing against the cold stone of impossible equations. He was lonely, he was underpaid, and he was being ignored by the very people he sought to enlighten. Yet, there was a stubborn, quiet fire in him. He knew the world was wrong, and he knew that time, the very thing he had redefined, was on his side. He would wait. He would work until the sheer elegance of the truth became too bright for the world to turn away from. The rejection was merely the shadow cast by the light he was bringing, and he was prepared to walk through that shadow for as long as it took to reach the stars. The years of rejection and bureaucratic solitude finally gave way to a relocation to Berlin, the epicenter of the scientific world. But the transition brought no peace. From 1912 to 1915, Albert was a man possessed, a specter haunting the halls of the Prussian Academy of Sciences. He had moved beyond the simple, flat world of his first theory. He was now chasing a much larger beast, the very curvature of the universe. He was older, his face etched with the lines of a deteriorating marriage and the crushing weight of an intellectual struggle that felt like a physical war. He sat in his study, the air thick with the smell of cheap tobacco and the silent screams of discarded calculations. He was attempting to translate the poetry of his happiest thought into the rigid, unforgiving language of non-Euclidean geometry. He realized that time and space were not just a stage, they were a fabric, a four-dimensional sheet that was not flat, but flexible. Imagine a trampoline, pulled tight. This was space and time in its empty state. If you place a heavy bowling ball, the sun, in the center, the fabric stretches and sags. It curves. Now, if you roll a smaller marble, the earth, across that fabric, it doesn't move in a circle because of a mysterious tug of force. It moves in a circle because the very ground beneath it is curved. The marble is simply following the shortest path through a warped landscape. Gravity was not a ghost, it was geometry. And because space and time were one, if space was curved, time had to be curved too. Near a massive body, the fabric of space-time was stretched so thin that time itself slowed down. A clock on the surface of a star would tick slower than a clock floating in the void. It was a terrifying, beautiful vision, the universe was a living, breathing landscape of hills and valleys, carved out by the weight of the stars. But the math was a nightmare. Albert felt he was losing his mind. He was using a form of mathematics called tensor calculus, a language so complex that only a handful of people in the world understood it. He would work for 18 hours straight, forgetting to eat, forgetting to sleep, his fingers blackened by lead and ink. He was in a race against his own exhaustion and a rival, the great mathematician David Hilbert, who was also closing in on the solution. In November 1915, the fever broke. In a series of 4 lectures at the Academy, Albert unveiled the general theory of relativity. The final equation was a thing of terrifying simplicity. On one side, the geometry of space, on the other, the distribution of matter. It was the bold one's secret code, finally cracked open. However, a theory, no matter how beautiful, is just a story until the universe confirms it. Albert realized his theory made a radical prediction: if space is curved, then a beam of light passing near the sun should not travel in a straight line. It should bend. It should follow the curve of the warped space. The problem was that the sun is so bright that one cannot see the stars behind it to measure if their light is bending. The only time the experiment could be performed was during a total solar eclipse. In 1919, after the horrific bloodshed of the Great War had finally ceased, a British expedition led by Arthur Eddington traveled to the island of Principe, off the coast of Africa. They waited for the moon to slide in front of the sun, for the day to turn into night, so they could photograph the stars. Albert remained in Berlin. He was sick with a stomach ailment, his body finally rebelling against years of neglect. He waited for a telegram. On September 22nd, he received it. The stars had shifted. The light had bent. The universe had obeyed his mind. He was sitting with a student when he read the news. He showed her the telegram, his expression remarkably calm, almost detached. "What would you have said," the student asked, "if the results had not confirmed your theory?" Einstein looked at her with a faint, enigmatic smile, the same eyes that had once stared at a compass in a Munich bedroom. "Then I would have felt sorry for the dear Lord. The theory is correct." Overnight, the world exploded. The man who had been a lonely patent clerk was now the most famous person on the planet. The headlines screamed, "Lights all askew in the heavens and Einstein triumphs." Humanity, weary of the darkness of war, looked to this wild-haired man who had unraveled the stars. He had reached out into the darkness and found that time was not a cage, but a river, and that we were all drifting on its beautiful, curved current. He had discovered the shape of the void. The fame that followed the eclipse of 1919 was a deafening roar, a tidal wave of flashbulbs and newsprint that threatened to drown the man who only wanted to think in silence. Albert Einstein became a global icon, his face a shorthand for genius, his name a synonym for the incomprehensible. Yet, as the decades turned and the world transformed through the fires of another world war and the dawn of the atomic age, his discovery of time began to migrate from the chalkboard to the very machinery of civilization. He had died in 1955, leaving behind a world that was only just beginning to build the tools sensitive enough to prove him right. The transition from the mid-century to the modern era saw the thought experiments of a patent clerk become the engineering requirements of a global species. The universe, it turned out, was exactly as strange as he had imagined, but with a precision that was almost haunting. In the late 20th century, humanity launched a constellation of artificial stars into the silence of orbit, the Global Positioning System. These satellites, hurtling through the vacuum at thousands of miles per hour, carried within them the most accurate timekeepers ever devised, atomic clocks that measured the vibrations of atoms, ticking billions of times per second. But the engineers quickly encountered a ghost in the machine. Because the satellites were moving rapidly relative to the people on the ground, Einstein's special relativity dictated that their clocks should tick slightly slower, about 7 microseconds a day. Simultaneously, because they were thousands of miles above the Earth, farther away from the planet's mass and its gravitational sag in spacetime. General relativity dictated that their clocks should tick slightly faster, about 45 microseconds a day. The two effects did not cancel out. Without Einstein's equations, the clocks on the satellites would have drifted by 38 microseconds every single day. It seemed like a negligible amount, a mere heartbeat in the life of a city. But at the speed of light, 38 microseconds translates to a distance error of 10 kilometers. Without the corrections for the warping of time, every GPS-guided ship would lose its way, every smartphone map would point to the wrong street, and the synchronized pulse of the modern world would collapse into chaos. We had built a world that relied on the fact that time is not the same for everyone. Every time a person looks at a screen to find their way home, they are participating in a silent dialogue with a young man in Bern who wondered about a beam of light. The proof didn't stop at the edges of our atmosphere. In the second decade of the 21st century, humans built massive, L-shaped tunnels called LIGO, designed to listen to the very breathing of space. In 2015, exactly a century after Albert had finalized his general theory, these sensors detected a faint, rhythmic shudder, a ripple in the fabric of spacetime itself. It was a gravitational wave, a sound produced by the collision of two black holes over 1 billion years ago. The collision had been so violent that it had sent waves out across the universe, stretching and squeezing space and time like a bell being struck by a hammer. When those waves reached Earth, they moved the mirrors of the detector by a distance smaller than the width of a single proton. It was a measurement of almost impossible delicacy, yet it was there. The universe was ringing. Space was not a void, it was a medium that could vibrate. Time was not a line, it was a surface that could ripple. The modern world has become a testament to his solitude. We have seen the shadows of black holes, regions where gravity is so intense that time effectively stands still, a frozen horizon where the now of the universe ends. We have sent probes into the deep dark, finding that the stars are positioned exactly where his math said they would be. The patent clerk's daydream has become the bedrock of our reality. We no longer live in the clockwork universe of Newton, a world of rigid certainties and absolute measures. We live in Einstein's universe, a fluid, shimmering, interconnected tapestry where the motion of a finger and the birth of a galaxy are woven into the same elastic thread. Technology has not just proven him right. It has made us inhabitants of his imagination, travelers in a world where time is a mountain we are all climbing at different speeds, forever looking back at the summit he reached alone. The light in the Princeton study was different from the light in Bern. It was softer, filtered through the heavy branches of American elms, casting long, contemplative shadows across the piles of paper that still littered Albert's desk. He was an old man now, his face a roadmap of a century that had seen more change than any other in human history. His hair was a wild, snowy crown, and his eyes, though tired, still held that same spark of defiant wonder that had ignited when he first held his father's compass. He sat by the window, a violin case resting unopened in the corner. He no longer felt the need to chase the light. He had lived within it for 76 years. He looked at his hands, veined, spotted with age, the skin thin as parchment. To the world, these were the hands that had dismantled the heavens. To him, they were merely the instruments of a brief, flickering consciousness trying to make sense of the infinite. He knew his own time was drawing to a close. But time had lost its sting. For Albert, the distinction between the past, the present, and the future was nothing more than a stubbornly persistent illusion. If the universe was a four-dimensional block of spacetime, then every moment he had ever lived, the fevered child in Munich, the defiant student in Aarau, the joyful father in Bern, still existed. They were not gone, they were simply at different coordinates in the grand, unchanging geography of the cosmos. He thought of his old friend Michel Bessot, who had passed away only a few weeks earlier. Albert had written to Michel's family, telling them that his friend had merely departed from this strange world a little ahead of me. It wasn't just a comforting sentiment, it was a physical conviction. In the tapestry of relativity, the death of a star or the death of a man is just a fold in the fabric. The person remains woven into the structure of reality forever. He looked out at the evening sky, where the first stars were beginning to pierce the violet dusk. He realized that the greatest discovery he had made wasn't an equation or a theory, but a feeling. It was the realization that the universe is not a cold, mechanical accident, but a coherent, harmonious whole. There was a logic to the light. There was a melody to the motion of the planets. He had spent his life trying to hear a few notes of that cosmic music. And the music had been more beautiful than he could ever describe. Time, he finally understood, was the ultimate gift. It was the medium through which the universe experiences itself. It was the slow unfolding of a flower, the patient erosion of a mountain, the quickening pulse of a lover. By proving that time was relative, he had liberated humanity from the prison of the clock. He had shown that we are not merely victims of a ticking second hand, but active participants in the creation of our own duration. We are the ones who give time its meaning. He picked up a pen one last time. He wasn't writing for a journal or a university. He was scribbling a few final thoughts, a bridge into the unknown. He felt a profound sense of peace. The mystery of the compass was solved. The beam of light had been caught. The curvature of the world had been mapped. He had done what he came to do. As the sun dipped below the horizon, plunging the room into a warm, amber glow, Albert Einstein closed his eyes. He felt the familiar sensation of falling, that weightless, happy thought of freefall. But he wasn't falling toward the earth. He was falling into the stars, drifting back into the vast, curved embrace of the space-time he had spent his life defining. The clock on the mantelpiece continued to tick, a lonely, mechanical sound in the stillness. But for the man in the chair, the ticking had finally merged into the eternal, silent hum of the universe. He was no longer a traveler through time. He had become part of the light.